Principal component analysis is a popular technique in data analysis to turn a bunch of variables into a smaller number of meaningful combinations. And in today's video, I'm happy to share that I've teamed up with Joachim from Statistics Globe to teach you a whole lot about PCA. The content of today's video is only a part of what Joachim is going to teach you in his upcoming video course about PCA, so definitely check that out if you are interested in that. And with that said, Joachim, the stage is yours.
Thank you so much, Albert, for the opportunity to speak on your channel and to introduce my online course on principal component analysis to your audience. In this video, I will speak about variable loading plots, which are very popular plots when it comes to PCA. And in this video, I will demonstrate how to create such plots in R programming. So without further ado, let's jump right into the video. In this video, we will only have to install and load the Facto-Extra package, as you can see in lines 2 and 3 of the code. I have installed this package already, so for that reason I'm just going to load it. And please note, the Facto-Extra package also automatically loads the ggplot2 package, so now we can also use the functions of the ggplot2 package. In this video, we will use the empty cars dataset as an example data frame, and we can load empty cars by running line 5 of the code. So after running this line of code, a new data frame object called empty cars is appearing at the top right. And we can have a look at the first 6 rows of this data set by applying the head function, as you can see in line 6 of the code. And now you can see that the empty cars data set contains different information about cars. In this example, I want to reduce the size of the data set a bit for the examples, and I can do that, as you can see in line 8 of the code. So after running line 8 of the code, a new data set called my data is created, and this data set contains only some of the columns in which I am interested in. Now, in this tutorial, I want to show you how to apply a principal component analysis and then how to create a loading plot based on these results. And in order to apply a principal component analysis, we have to use the prcomp function, as you can see in lines 11 and 12 of the code. And within this function, we have to specify the name of our dataset. So in this case, our dataset is called myData. And it's also important to set the scale argument to be equal to true, because this standardizes our data. And if we want to apply a PCA, it always is better to standardize your data, because otherwise variables with more variation will have a larger impact on the principal components. And since all our variables should have the same impact, we scale our data when applying a principal component analysis. By the way, please note that we have created a comprehensive online course at Statistics Globe in which we explain how to apply a principal component analysis in R programming, and we also explain the theory behind PCA. So if you are interested in this topic, make sure to check out the description of this video, because in the video description we will put a link where you can find more details about the course. However, now let's move on and apply the principal component analysis in lines 11 and 12 of the code. So after running these lines of code, a new PCA object called myPCA is created. And we can now have a look at the summary statistics of this PCA object by applying the summary function. And then you can see that we have created a data set with 6 principal components. So a principal component analysis always creates the same number of principal components as we have variables in our original data. And then it also shows certain metrics, such as the standard deviation, the explained variance by component. So here you can see that the first principal component already explains almost 70% of the variation in our data. And then when we add the second component, another 19% are added. And you can see the cumulative explained variance in the bottom row. So you can see after adding 2 principal components, already 88.92% of the variance is explained. However, in this tutorial, we don't want to focus on the principal components and their importance. In this case, we want to focus on the loading plot. And we can create a loading plot, as you can see in line 16 of the code, by applying the fwith_pca var function to our PCA object. So after running line 16 of the code, a new graph is created at the bottom right. We can enlarge this graph by clicking on the zoom button, and then you can see that we have created a variable loading plot. And in this plot, you can see the first principal component on the x-axis and the second principal component on the y-axis. In this plot, the principal components are called dim1 and dim2. And then you can see the 6 variables in our data set, and for each variable an arrow which points in a certain direction. And in this variable loading plot you can see how these variables are related to each other. So if two variables point in the same direction, they are positively correlated. If they point in opposite directions, they are negatively correlated. So for instance, you can see that the variables disp and mpg are strongly negatively correlated. In contrast, for example, disp and wt are highly positively correlated. In this plot you can also see the contribution of those variables to the principal components. So if a variable is pointing in the direction of the axis of a component, it's contributing more to this component. So for instance, the variables disp and mpg contribute a lot to the first principal component because they are very close to the axis of this component. In contrast, the variables qsec and dread are corresponding more to the second principal component. We can also compare these results with a simple correlation matrix, and we can create such a correlation matrix as you can see in line 18 of the code. So in this line of code, I'm applying the cor function to our data set, and then I round the values to 2 digits to make it easier to read. So after running lines 18 and 19 of the code, our correlation matrix is shown at the bottom in the RStudio console. And remember, we saw in our loading plot that the variables disp and mpg are negatively correlated. And if we compare that now in our correlation matrix, you can see that the negative correlation is very high. In contrast, we saw that the variables disp and wt have a strong positive correlation, and you can also see that in the correlation matrix. So if you have a look at this value, you can see that the correlation of these two variables is 0.89. It's also possible to add some colors to our plot by using the col_var argument, as you can see in lines 21 and 22 of the code. So in this case, I want to color our arrows based on their contribution to the principal components. So after running lines 21 and 22 of the code, you can see that our graph is updated. And as you can see on the right side, there's a legend which indicates the strength of the contribution of our variables. So the lighter blue a variable is shown, the higher is the contribution. So for example, you can see that the variable qsec has a very high contribution, while on the other hand, the variable dread has a relatively low contribution. We can also change the colors of this range, as you can see in lines 24 to 28 of the code. So in this case, I'm adding the gradient cals argument. And as you can see, we can even add more than 2 colors to this argument. So in this case, I want lower contributing variables to be appearing in green, medium variables in yellow, and strongly contributing variables in red. So after running these lines of code, you can see that our plot is updated. And as you can see, the variable dread, which is contributing the least, is shown in light green, whereas qsec, which is contributing the most, is shown in red. A very convenient thing about these plots is also that you can combine them with ggplot2 syntax. So as you can see in lines 30 to 38 of the code, in this case I modify my plot using ggplot2 syntax. So in this line I'm adding the ggtitle function to our plot to change the main title. Then I change the x and y labels, and I also change the legend title. So after running these lines of code, our plot is modified once again. And as you can see, now we have labeled our axes to PC1 and PC2. We have changed the title of our plot to variable loading plot, and we have changed the legend title to variable contribution. Thanks again, Albert, for this opportunity and for putting a link to my online course into the description of this video. Make sure to check it out and then hopefully see you soon in the course. Bye bye.